As we said before, the idea of neural network has been proposed for many years. So around 1980s, there are many researchers working on neural network. However, from the beginning of 1990s, the research track diminished when many people found that they don't have the ability to train a good neural network. But right here, maybe starting from the year 2012, the research trend emerged again. That is because of the development of a new training algorithm and the new powerful device. So the deep learning, the difference between deep learning and the conventional neural network is mainly on the layer of the hidden layer, the numbers of hidden layer. Okay, so why deep? Why do we need deep? Why do we need many hidden layers? So in this paper published in 2011, that is mainly for speech transcription. They study the word error rate, okay, and the relationship of word error rate and the layer versus the size. Okay, so if we use one hidden layer, 2, 3, 4, 5, and a 7 hidden layer, the word error rate decrease. So there is no problem that when we increase the numbers of layer, then the word error rate decrease. Okay, so not surprise, more parameter, better performance. However, there is a universality theorem. That means any continuous function f that map from Rn to Rm, from that maps an n-dimensional vector to an m-dimensional vector. This function can be realized by a network with only one hidden layer. So we can put only one hidden layer, but put many neurons in this hidden layer. Then we can simulate any kinds of function. Okay, so given enough hidden neurons, we can use one hidden layer neural network to simulate any function. So why deep neural network, not fat neural network? Because here we just use one layer, and this is a very fat neural network. Okay, so why do we need to divide it a hidden layer that consists of many neurons into many layers, and then maybe each layer consists of fewer neurons? So why deep but not fat? So assume that we now have two neural networks. One is fat and short, like this. So we only have one hidden layer, and this hidden layer contains many neurons. So this is a shallow neural network, and this layer consists of many neurons. Another network is thin and tall. We have at least two hidden layers, and then at each layer we have fewer neurons. Okay, so if the numbers of neurons or numbers of parameters of these two networks are approximately the same, what is the performance difference? Okay, so this is a shallow neural network, and this is a deeper neural network. And in this paper, they do this comparison. Okay, so remember that when we use seven layers, and the word error rate is around 17%. Okay, so if we just use one layer, and this layer consists of more than 2,000 neurons. Okay, and then the numbers of parameters of the deep network and the shallow network are approximately the same. Then in this case, the fat network, the word error rate is around 22%. It's around 22%. And if we increase the numbers of neurons to 16K, we can reduce the word error rate to around 22%. And this value is just better than this case. But this case, the numbers of parameter is much smaller than this case. Okay, so by this simple performance experiment, performance evaluation, performance comparison, we see that there is a superiority of the deep neural network. But why? Why deeper is better? Without theoretical mathematical derivation, we give you several examples to show why deeper or divided component can be better. Okay, so for large network, for larger circuit, the larger circuit consists of gates, and a two-layer of large gate can represent any Boolean function. So using multiple layers of large gates to build some function are much simpler. Okay, in large gates, so less gates are needed. For neural network consists of neuron, and a hidden layer network can represent any continuous function. Although, even so, using multiple layers of neurons to represent some functions are much simpler. Okay, so we will use less parameters. So that probably implies we need less data to train a workable neural network. Another viewpoint is modularization. Okay, so imagine that if we try to recognize the girl with long hair, the boy with long hair, the girl with short hair, and the boy with short hair, then we may be able to construct four classifiers. Okay, so for the first classifier, it focuses on classify girls with long hair. Okay, for the second classifier, it focuses on classifying boys with long hair, and so on. Theoretically, this procedure is workable. However, we have much less training example of the boys with long hairs, so it may be not easy to construct the second classifier, or the second classifier cannot achieve very accurate result. So one way to improve this is to do modularization. We may be able to construct two basic classifiers. First, one classifier is to discriminate boy or girl. Another classifier is to discriminate long hair or short hair. Okay, and we are easy to collect many boy images and girl images, and we are also easy to collect many long hair images and short hair images. Okay, so first we may be able to construct these two classifiers to discriminate boy or girl, long hair versus short hair. And then we combine them. We combine them to construct these four classifiers. Okay, so we share by the following classifier as a module. And then we construct the more detailed classifier such that we may need little data to construct a classifier that can detect boys with long hair. So this is the viewpoint of modularization. So in a deep neural network, we can imagine that right now we have many hidden layers. Okay, and we can think about that. The first hidden layer discover the most basic classifier, construct the most basic classifier, and then the second layer use the first layer as the module to build the second layer classifier, and then to build the second layer, use the second layer as the module to build the third layer classifier, and so on. So it may be possible to do learning with less training data. And from the paper published in year 2014, we can also see the visual effect when we put many images in the deep neural network. Okay, so at the first hidden layer, the first layer may learn how to discriminate very basic component, very basic visual component like the green patch or orange patch or a simple edge pattern. And then at the second layer, we may be able to model higher level patterns like the periodic pattern, or some kinds of cross pattern. And then at a higher layer, then we may be able to learn important parts of specific object like the wheel, like a human face, or like a specific higher level patterns. So this is why a deep neural network may be uh, more powerful than a fat neural network.